While aerial encounters with unexplained objects receive most public attention, the transmedium capability demonstrated in the Puerto Rico incident suggests something far more advanced than unusual aircraft. These objects appear to operate with equal facility across environments that require radically different engineering approaches in our technology. The Puerto Rico incident stands as one of the most technically validated cases of transmedium UAP travel on record. The combination of military-grade tracking data, multiple sensor confirmations, and the object's unusual behavior creates a compelling case that defies conventional explanation. When considered alongside other underwater UAP encounters, it suggests we're observing technology that operates according to physical principles beyond our current scientific understanding. What was initially a routine border patrol exercise became an encounter that challenges our fundamental assumptions about the limits of technology and the physics of movement through different mediums. To fully grasp the significance of what was observed that day off the coast of Puerto Rico, we need to examine exactly how these objects appear to violate the basic principles of hydrodynamics. The physics-defying capabilities. The physics challenges these objects present fundamentally rewrite what we understand about movement through water. When examining the capabilities of these underwater craft, we must first recognize the basic physical properties that make their reported behavior so extraordinary. Water creates roughly 800 times more resistance than air. This difference isn't just significant, it's transformative in terms of the engineering challenges involved. When an object moves through water, it must displace that water, creating resistance that increases exponentially as speed increases. Double your speed, and you quadruple the resistance. This mathematical relationship imposes what engineers have long considered insurmountable barriers to high-speed underwater travel. Yet the unidentified submerged objects described by Elizondo appear to ignore these constraints entirely. According to his accounts, these objects move through water at speeds that make our fastest torpedoes look glacial by comparison. The physics problems this creates aren't minor engineering hurdles. They're fundamental violations of how we understand material objects interact with dense mediums. Perhaps the most striking physical impossibility involves cavitation. When objects move quickly underwater, the pressure differentials create areas where water effectively boils, forming vapor bubbles that then collapse violently. This process, cavitation, is both noisy and destructive. Any conventional object moving at high speed underwater creates these bubbles. Our fastest torpedoes, like the Russian Virginia 111 SHK Val, which reaches about 200 knots, actually utilize a specialized form of this phenomenon called supercavitation, deliberately creating a large gas bubble around the torpedo to reduce water resistance. The USOs described by Elizondo reportedly show no signs of cavitation whatsoever. They move through water at 450 to 550 knots without creating the vapor bubbles that physics tells us must form at such speeds. This absence of cavitation suggests these objects somehow modify the water around them or operate according to principles that negate normal fluid dynamics. The structural integrity displayed by these objects presents another seemingly impossible characteristic. Water pressure increases with depth, but pressure differentials also increase dramatically with speed. At 550 knots underwater, the pressure forces acting on any conventional material would be catastrophic. Materials science has strict limits on what substances can withstand such forces without deformation or destruction. Even our most advanced submarines, made with specialized high-strength steel alloys, operate within narrow speed parameters, typically maxing out around 35 knots, to prevent structural failure. These objects maintain perfect structural integrity despite forces that would crush any known material. They show no signs of stress or deformation despite moving at speeds where the pressure differentials should tear them apart. This suggests either materials far beyond our current capabilities or some technology that mitigates these forces in ways we don't understand. Some of the most perplexing reports involve objects that stop instantly underwater without any apparent deceleration period. This capability violates basic Newtonian physics. An object moving at high speed carries enormous momentum. This momentum cannot simply disappear. It must be transferred or converted through some process that requires time and distance. Even emergency braking in air requires significant distance. Underwater, where resistance is higher, instant stops should be even more impossible. Yet multiple military sensor systems have reportedly captured USOs that stop without the expected deceleration curve. This behavior suggests technology that either negates inertia or manipulates mass in ways our physics considers impossible. The energy that should be dissipated during deceleration simply vanishes with no apparent thermal or kinetic effects. Maneuverability at high speeds represents another physics violation. As speed increases underwater, the forces acting on control surfaces like rudders or fins become enormous. At very high speeds, conventional steering mechanisms become ineffective or even destructive. Submarine design accommodates this limitation by restricting tight maneuvers to lower speeds. The faster a conventional vessel moves underwater, the wider its turning radius must be. The USOs demonstrate perfect control and maneuverability despite traveling at speeds where steering should be impossible. They reportedly make tight turns and rapid course changes that would tear conventional craft apart. The G-forces generated by such maneuvers would be lethal to any human occupants and destructive to any known materials. The energy requirements for these movements present another insurmountable barrier for known technology. Moving at 550 knots underwater would require energy generation far beyond anything we currently possess in a mobile platform.